Hello students, I am Professor Sudhir Kumar Tewatia. I am BTech Civil from IIT Delhi, MTech from IIT Roorkee in Water Resources Development, and PhD from IISc Bangalore and DTU. I have been Vice Chancellor, Director, Dean in India and abroad. So today we'll start some problems and some tricks in numericals because time is short and we have to visualize so that we can do it in an easy manner. So this is the problem. A rocket is moving in a gravity free space with a constant acceleration of 2 meter per second square along plus x direction. Plus x direction. The length of chamber inside the rocket is 4 meter. A ball is thrown from the end of the chamber in plus x direction with a speed of 0.3 meter per second from this side. Another ball is thrown at the same time from this side. So this is 4 meter length. So now this is the problem 2014. So one way of attempting this problem as the student would usually do, like taking it in the x direction, but if you look at a bit closely on the problem, actually it is a problem of what we are doing in this chapter or in this topic. This is a problem of motion and collision in vertical line. You may ask, no sir, it is horizontal, it is in the x direction. So because if you visualize this, suppose you put the earth here, okay, now this rocket is not accelerating with A. Now this acceleration is this side, not earth or some planet. So this acceleration is acting on this A. This is equivalent. And now you rotate it by 90 degree. So this problem becomes like this. This is 0.2 meter per second. Acceleration A is equal to 2 meter per second square. This side throw 0.3 meter per second, and acceleration A is equal to 2 meter per second this side also. So this is a problem of motion in vertical line. It is asked after how much time they will collide. So you have earlier seen in the earlier problems there are two ways to collide for the particles as we discussed earlier. Number one, collision in the air. Number two, on the ground. So wherever they collide earlier, that is the answer. So let's check it. It's easy. What is the relative velocity? Time t earlier as we used to calculate of the collision, that was distance, relative distance, that is 4 meter divided by u1 minus u2, that is equal to 4 divided by 0.3 minus 0.2. So that becomes 4 divided by 0.5, 8 seconds. This is a question to check your presence of mind. Student is prompted to answer 8 seconds. And student is happy. Oh, I got the answer very easily. And he will immediately try to take 8 seconds. But no, just please stop. Let's check the another possibility. Because the speed and the velocity in both the directions as compared to acceleration is very low. So before they collide in the air, this particle will fall back on the rocket. And after that, this will come and hit it on the ground. So let's check what is that time? Okay, now we will see how much time it will take to fall on the ground. That may you may consider the collision on the ground. So for that, I earlier advised the student not to use the formula to calculate the time to fall on the ground. That formula S is equal to ut plus half gt square or at square, because it gives quadratic equation. Instead of that, we use this formula. V square is equal to u square plus 2as. So using this formula, we can get the velocity v. V is 4 meter per second. And once we get the final velocity 4 meter per second to hit the ground, it is actually minus 4 because velocity is downwards. So then we calculate from this equation v is equal to u plus at time. So time is v minus u by a. So 4 minus 0.2 divided by 2. So that comes out to be 1.9 second. So this 1.9 second is shorter than 8 second. So the particles will collide, the balls will collide on the ground, not in the air. And to give it final check whether they really collide on the ground, the second ball should be on the ground before the first ball strikes the ground. So for that, we calculate for lower ball time to fall back on the ground or rocket ball. So time of flight of the ball is t is equal to 2u by a, because that ball is thrown by velocity 0.3 meter per second in the upside. So by this formula, we take this ball will come back on the wall or on the ground within 0.3 second. So that is less than 2 second. So the 2 second is the answer. That's all. Thank you.